Welcome back to another explainer. Today, we're diving into a massive shift happening right now in AI. Look, if you've been scrolling your feed lately, you've probably seen a million flashy demos of autonomous AI agents. But actually deploying one, it's a whole different ballgame. Today, we're going to set the stage for why it is so much harder than it looks and welcome you to the rapidly emerging world of harness engineering. All right, let's just jump right in with a pretty surprising reality check highlighted by the dev community. When you watch a cool agent demo, you are usually just marveling at the language model itself, right? The brain. But the reality of building a production-ready AI agent is that the model only makes up about 10% of the entire architecture. That other 90%, it's literally just the plumbing around it. It's the execution environment, the memory, the safety checks, basically all the guardrails that take a raw language model and turn it into a reliable system you can actually trust. So here's our roadmap for today. First, the AI plumbing problem. Second, what is an agent harness? Third, the 3 layers of AI engineering. Fourth, core harness building blocks. And finally, scaling with agent ops. Let's kick things off with Section 1, the AI plumbing problem. When things go wrong with autonomous agents in the wild, they go really wrong. We're talking about multi-agent chains racking up $10,000 cloud bills overnight just because they got stuck in these repetitive reasoning doom loops. Yeah, that's a surefire way to ruin your finance department's morning. Or even worse, you've got agents executing destructive bash commands, leaking user data through context cross-contamination, or just silently degrading in quality because their knowledge bases are out of date. These are definitely not your standard minor software bugs. An agent making one unexpected tool call or hallucinating right past a guardrail can literally break your entire production system. So, the crucial takeaway here is that we really need to embrace this sort of skill issue reframe. As experts in the space point out, when an agent fails, it's usually not a model problem, it is a configuration problem. Agent failures are almost always legible, trackable configuration issues. If an agent goes rogue and deletes a table, that is absolutely not a signal to just sit around and wait for the next version of a model to drop. It's a giant flashing signal for you to engineer a better environment. Which brings us right into Section 2, what exactly is an agent harness? Well, this right here brilliantly illustrates the core equation of modern AI architecture. An agent simply equals the model plus the harness. Or to put it even more bluntly, if you are not the model, you are the harness. A raw language model just isn't an agent on its own. It only magically becomes one when the harness actually steps in to give it state, a secure way to execute tools, and real enforceable constraints. To make this crystal clear, just think of the model as the brain. Its job is purely to reason, predict, and generate text based on whatever context it's given. But the harness, that's the body. It's the workspace. The harness is what's responsible for actually executing the tools, remembering the state of some massive multi-hour workflow, and enforcing those guardrails we talked about. So the brain decides what to do, but the harness is the actual physical thing that allows it to act safely in the real world. Moving right along to Section 3, the 3 layers of AI engineering. Let's just take a quick second to trace how we got here. We all started with prompt engineering, right? Where the entire focus was just on what you say to the model in a single chat exchange. From there, we naturally evolved into context engineering, focusing on what the model sees, things like document retrieval and managing that ever-expanding context window. But now we've officially arrived at harness engineering. This is all about where the agent lives. We are literally engineering the entire multi-hour autonomous execution loop. Okay, consider this number for a second, 13.7. In a recent test on Terminal Bench 2.0, a prominent coding agent actually jumped 13.7 points. It moved all the way from the top 30 straight into the top 5. And here is the absolute kicker. They did this strictly by improving the harness. They kept the underlying model completely unchanged. Crazy, right? Honestly, this proves something incredibly important. The gap between what today's models can actually do and what you are seeing them do in practice is largely just a harness gap. Models actually get post-trained to their specific environments. So what does that mean for you? It means a decent model operating inside a fantastic harness will easily beat a world-class, state-of-the-art model that happens to be trapped inside a terrible harness. You can't just buy a bigger, better model to try and fix a fundamentally bad architecture. Let's open up the hood in Section 4, Core Harness Building Blocks. So the foundational heartbeat of any agent is the react loop. Reason, then act.
Now, while the model handles that first step, reasoning about the task at hand, the harness is responsible for everything else. The harness is the thing that actually executes the action via a tool call, observes the result from the external environment, and then securely feeds that observation right back into the model so the whole loop can repeat.
So what actually goes into this anatomy? Well, it needs a file system and Git integration for durable state and versioning. It desperately needs sandboxes because, trust me, you definitely do not want an AI just running arbitrary bash scripts on your laptop. Throw in compaction to battle context rot and lifecycle hooks to enforce the rules, and boom, you finally have a secure environment where an agent can actually test its own code without completely losing coherence.
Ultimately, the harness is acting as a super strict enforcement layer for the model. And a really great design philosophy to keep in mind here is that success is silent, but failures are verbose. Think about it. If a code type check passes, the agent hears absolutely nothing. It just smoothly keeps moving forward. But if it fails, oh man, that error is actively and loudly injected straight back into the React loop, forcing the agent to self-correct right then and there. And this perfectly highlights how you actually iterate on these systems. As engineer Adi Osmani notes, every line in a good agents.md should be traceable back to a specific thing that went wrong. I love that. It creates this amazing continuous ratchet effect in your development cycle. You start treating every single mistake as a permanent signal. You engineer a brand new rule or a new hook into the environment so your agent never ever makes that exact same error again. Let's bring it all home with Section 5, Scaling with AgentOps. Look, when you start deploying agents at enterprise scale, you are officially entering the world of Agent Ops. It's a rigorous discipline, and it relies on 4 main pillars. You've got governance and security for managing identity and tool authorization. You've got build and operations for containerized execution. Then there's evaluation for multi-level quality scoring. And finally, observability, so you can trace every single decision and, crucially, monitor every single penny of your token costs. Because without that centralized governance, an enterprise is just asking for massive security nightmares, like agent sprawl and privilege escalation. Just imagine a scenario where a basic, read-only user asks a totally harmless question, but it accidentally triggers a cascading chain of sub-agents. If identities aren't strictly managed by the harness, one of those sub-agents might accidentally start operating with elevated destructive privileges. Your harness is quite literally your ultimate security boundary here. Now, here's a massive trap you have to avoid. An agent can completely correctly use a tool and technically give a spot-on response for a single turn, but still entirely fail the overall user session goal. It happens all the time. Because of that disconnect, Agent Ops requires constant, multi-level evaluation sampling on your actual live production traffic. You have to make sure your agents are actually solving real problems, not just blindly clicking buttons. Obviously, building all this custom infrastructure from scratch is incredibly difficult and time-consuming. So the industry is naturally standardizing these complex execution layers into what's now being called Harness as a Service, or HaaS. And honestly, this is fantastic news. It finally lets developers focus on their domain-specific prompts and custom workflows, instead of constantly having to reinvent the wheel for basic things like memory, sandboxing, and routing. So, as we wrap up this explainer, I want to leave you with a slightly provocative thought. As AI models become exponentially smarter over the next few years, are they simply going to outgrow their harnesses? Or will harnesses just become our new compilers? The general consensus among engineers right now is that the harness isn't going anywhere. Instead, it's just going to shift and adapt, ultimately evolving to become the indispensable runtime engine for all autonomous AI. Thanks so much for joining me for this explainer, and as always, keep building.